Hi, this is a quick tutorial on how to set up an OpenCV programming environment using on Windows, using the Visual Studio compiler, using VS Code as our text editor, the latest OpenCV 4.1 or whatever, and the CMake build engine. So you'll need these 4 installers, and I will provide links to them. So the first thing that we'll install is VS Build Tools. So this particular application provides the compiler of Visual Studio without requiring the installation of the entire environment. So we will launch it, and all we want is the C++ build tools. So we will click install after that and wait for it to finish. Okay, well, that wasn't too hard. Okay, since we're done with that, we can close out. The next step for us will then be installing the CMake build tools. So we will go through the installation of this software and make sure to add it to the system path for all users. We'll click yes. If you can only add it to the system path for one user, that's fine, but also I don't know how you'd install Visual Studio that way. Okay, now the next step is installing OpenCV. So the OpenCV installation itself isn't really an installer, it's just basically a zip file. So let's just extract it to our C drive. Might take a second. Okay, and that's really all you need to get that set up. You will see that if you go to C, OpenCV, you have the installation in this build folder. So the next thing we have to do after that is set our environment variables. Otherwise, CMake will get confused. So the process to do that is search for environment variables, open system properties, edit, and we're just going to set some user variables here. So first one, we're going to add a new one called CMake prefix path. This is just going to tell CMake where to look for the files that tell it what OpenCV is. So browse directory, PC, your C drive, OpenCV, build, and that's it. Then the next step is editing your path so that at runtime, it knows how to actually run OpenCV. So we're going to edit that one. I'm going to click New, Browse, go to the same location but slightly different. So OpenCV, Build. We're going to go to 64, VC15, and then Bin. Click OK, 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 and we're OK. So the final step is now actually installing Visual Studio Code. So we're going to accept the agreement, install it wherever, do whatever we want with it. Okay, so now we can go into VS Code and proceed to configure it. So we will want to install a couple extensions. So we will click on this extensions icon here. And the first thing that we're going to install is the CMake tools. So make sure to install the one that is offered by Microsoft. Click install. Okay. And the next step is to install the C++ tools. So we can search for that. And let's make sure to install this one. So we can click install here. And now, as of that, we should have all the extensions and software installed that is necessary to continue. So now let's open a folder. You can also get to that from the File menu. We will create a new folder for our first project. Let's call it something like CV test for computer vision test. Select folder. Okay. So this has opened VS Code with our folder that has no files in it right now. So the first thing we're going to want to do is to use CMake tools to create a new CMake project for us. So the way that we can do that is by pressing Control-Shift-P to open up the command palette, as they call it in VS Code, and search for CMake Quick Start. So selecting that and pressing Enter, we will get this message initially. Okay, no CMake kits are available. So we will want to scan for kits. So that will look around our computer and figure out what options we have to compile with. So it's going to give us these options. We are going to want to use the AMD 64 so we can compile 64-bit programs. This is important because we downloaded the 64-bit version of OpenCV. So let's name our project. In this case, we will call it CV test. Press enter. And we want to create an executable file because we are making a program. And we will press enter there, and we will see it start to configure. So we see here configuring using Ninja CMake generator. If it doesn't say Ninja CMake generator, then you have a problem and you should figure out why it's not using Ninja. This tutorial will probably not work if that is the case. Okay, so we just missed those notifications, but those ones were actually important. So we got some questions here. So this one is not important. This one is going to say, we'd like to configure IntelliSense for this folder. That is important because that will allow us to do syntax highlighting and code auto-completion in our C++ files. So we'll be able to click Allow. And would you like to configure this project? We just did, but I'll just click yes anyway to make it happy. Always configure projects upon opening. Sure, why not? Okay, so we see the CMake list file is going to describe our build environment. So we have a project named CV test, and the version of it is 0.1. So as you work on your project, you can increment the version. This is to allow unit testing. That is not in the scope of this video. This code, this line says we want to create an exe file called CV test, and we want to give it the main.cpp as its source file. As we progress forward with the project and we add more source files or header files, you are going to want to add them here. That is some additional boilerplate code. So it generated this hello world C++ file for us. So this will just run and print out a nice little message for us to show that everything's working. So let's build the project. So the way to do that is to look down at the bottom of the window where there's this gear icon and it says build. We will click on that and it will build our first source file and then make the executable file. And it succeeded in this case. There were no errors or other warnings. So now to run the program, we can observe that it will have put the program in this special build folder as cvtest.exe. So we could just go to that folder and run it directly. But let's use the built-in Visual Studio Code debugger to do this. So to do this, we will click on this little icon down here of a bug, launch the debugger for the selected target. So we'll click on that. We'll click on the executable file. Okay, it ran the program, it exited almost immediately, and it printed out this nice little message for us, which is exactly as we expect. So let's close out of the debug environment by going back to File Explorer, and output doesn't really matter. So Now let's make this project a proper OpenCV project. So we will go to CMake list.txt and we want to add the libraries. So right here, we will add a couple lines. First is find package OpenCV required. So this lets CMake know that we are looking for the OpenCV library, and that if we can't find it, then print out a big error message. And the next one, find package threads required. That is necessary for OpenCV because it has some built-in multi-threading. Now we are going to make a couple slightly unrelated from OpenCV changes, but we are going to want to set the version of C++ we want to use. So let's set the C++ standard to C++ 11. I'm setting it to 11 because I know C++ 11. If you want to use 14 or 17 or 21, whenever it comes out, pick that appropriately. And we're also going to set CMake CXX standard required on to print out a big error message if there's a problem doing that. And now finally, we are going to instruct it to use the OpenCV package that we just looked for. So we will add the include directories line, and we will want to add in the OpenCV include directories. So OpenCV include dirs. So what this does is when find package finishes, it will set a bunch of variables. One of the variables it sets is called OpenCV include directories. So that is just the path to the folder with all the headers in it. So if we go on my computer, that will take us to this folder, which has a header file in it. So after that, we want to link the library, target link libraries. This is just essentially saying that after we build against OpenCV, we want to link it, and this is required for the program to be able to use the library. So we want to use another variable called OpenCV_libs, which is the library files. If you want to know where those are in build, x64, vc15, bin. That is actually this one DLL file here, which is a very big DLL file that it's going to link against that contains all of OpenCV. So the next thing is we want to also link against our multi-threading libraries. So in this case, the variable is CMake thread libs init. And that is all the changes we have to make to CMake lists. So we will save that file, and we can then go and rebuild the project. It's automatically going to reconfigure the project as we just saw, and then build it again, and it succeeded. And we can run it again. So we can run it again, but there won't be any changes because we didn't make any changes to the source file yet. It just proves that it works. So let's actually go make this project a real OpenCV project now. So let's change this to something more reasonable. So like starting OpenCV project. And now we want to include the OpenCV libraries. So we have hash include opencv2/opencv.hpp. So this includes every OpenCV header file in the entire library. So let's save this, and let's just make sure it builds correctly. Build, and we can run it again. Check the debug console. Okay, that worked. Just making sure this didn't mess up anything. So now we can actually add some code to do a real computer vision task. So let's open an image using the imread function, and then we can display it in a window using other OpenCV functions. So we want to set a specific file we want to open. In this case, I'm going to use one I downloaded earlier from Google Images. So that is the file that we want to use. So now we can read the file using the imread function of OpenCV. So imread, image read, file name. That will tell it to read in an image. I'm using auto everywhere because it's convenient, but the data type that it's replacing is CV mat, which is a matrix, essentially. So now we can go through the next steps of using the OpenCV GUI libraries to display it on the screen. So we can type CV imshow, and then whatever we want the window to be called, let's call it image, and then we want to display this matrix on it. And now we call CV wait key. And if we pass 0 parameters, it will wait forever. It'll keep the image open until we press a key. And then so we can save this file, build it, and it built successfully. And we can run it again through the debugger. And we see here that it displayed the image in a little window here. And since we use the wait key function, we can just press any key to close the program. And that worked as expected. So there you go. This was a brief tutorial of setting up a build environment for OpenCV using the Visual Studio compilers in Visual Studio Code with CMake. One of the main advantages of CMake is that this CMake list file is very operating system independent. So you should be able to take this entire project here. You can upload this to GitHub or some other website, and you can download it onto a Linux computer that, assuming that you've installed OpenCV and CMake and a compiler on that Linux computer, you will be able to build and run this project just as quickly as we were able to here, without any changes to this file. Well, you would have to change the file name to run on a different system, but you probably won't have hard-coded file names in a final project anyway. So there you go. Further references are the official OpenCV documentation at docs.opencv.org.